calculus, okay? And that the famous problem is called tangent line problem. We want to motivate the topics that we are going to introduce, okay? So this part of calculus was invented in order to solve the tangent line problem. So what is going to be there? The tangent line problem. Okay, so what is going to be the tangent line problem? We are going to have a curve, okay, a function. So what would we like to do? We'd like to write the equation of a tangent line to the graph of the given function. So this is the question. Find the equation. Okay, find the equation of a tangent line. Equation of a tangent line to the graph. Okay, to the graph of this function. Okay, graph of the function. Graph of the function y equal to the f of x. Okay, y equal to f of x at a point with x equal to the a. That is the question. We call it tangent line problem. That's the foundation of calculus. You will see in a minute. Okay, so how are we going to solve it? This is going to be the solution of this problem. Let's see what we have and what we should do. You see, this is going to be, suppose this is the graph of your function. Okay, this is going to be the one. And suppose a function is given to you. Okay, this is going to be a function. The graph of the function is going to be y equal to the f of x. Then they pick a point here. Okay, a point. So this is going to be x equal to the a. Okay, this is going to be x equal to the a. So that gives you a point on the graph. You may call this point P. The coordinate of this point, you see if you want to find the y coordinate, this is going to be f of a. So we have a point here. We have a point P, the coordinate is x is equal to the a. We drop the a into the function, we get the y coordinate, f of a. Okay, so this is going to be a point that we have. This is a point. You want to find a tangent line, equation of a tangent line to this graph. Okay, then when you write the equation, when you get the equation of a tangent line, you see we don't have any idea of a tangent. What is the tangent line? Okay, so the tangent line, you may think about that. Oh, the tangent line is going to be a line that intersect the graph at one point. This is from the past. Let's suppose you are right. Okay, so you are looking in this type of line. We call it T for the tangent. Okay. Now, suppose, so we want to find the equation of the line. Let's see what you want. Do you remember how we're going to write the equation of the line? Or what is the formula for the equation of the line? Any suggestion? In order to write the equation of the line,
y equals mx plus b.
mx plus b. So what is m? What is m?
The slope.
The slope. Very good. So what we need the slope. Okay. So in order to get it, this is going to be a point. This is a point. In order to be able to find it, we need the slope. So what's going to be the slope of this line? Okay. You may call the slope m. Okay, m or mt, it doesn't matter for this line. Now, if you have the slope and a point, equation of the line would be this formula: y minus y1 equal to m times x minus x1. This is how we write the equation of the line. That mx plus b is when you simplify it, you get mx plus b. But in general, you need a point and you need the slope. to be able to write the equation of the line. Okay, so we already got there. We already got the point. So you have to find the slope, okay, to get these numbers. Okay, what is the formula for the slope? Do you remember the slope? How we're going to find it, or what's the formula? The formula that you have for the slope is when you have 2 points, remember? In order to find the slope, this is the formula for the slope. M is equal to the y2 minus y1 over x2 minus x1. So if you have 2 points, then you can find the, okay, you can find the slope. So the question is going to be, this is it. How are we going to find this the slope of this line? Okay. Now, in the history of calculus, they did have another problem at the beginning. The problem was, how are we going to define a tangent line? You see, the idea that you have for the tangent line is from geometry. In geometry, you can have a tangent line to a circle. It's not the case that you say, oh, this is the line that intersects the graph at one point only. No, it's not. You may have a graph that with this would intersect at several points. So you cannot use that idea. So what the mathematician, they did it for the first time, Isaac Newton, the English mathematician or physicist. The way he described this, solve this problem is he just gets some help. So what's the help? He just said, oh, suppose we consider this problem for a circle. That's history. So it's nice to know the history, then you can solve the problem because the solution is coming from history. So that was their interpretation. If you have a circle, and a line outside the circle, you see this line is going to be outside of the circle. This is originally. So what they do is we just move these lines towards the circle. When you move it towards the circle, this line first would intersect the circle. We cut it. Okay, so when we cut it, we get this one. You see, this is going to be the circle. And this is the circle. And this is the line that we talk about. You see, this is going to be the line. So this line would intersect the circle at 2 points. One of them is already given to you, P. So this is going to be a point P. Okay, this is going to be another point. We call it Q. Okay, so the point P is already given to you. So what you do is you pick another point Q. This Q is arbitrary. You can pick anything you like. So far, what we are going to have is we have the P. The coordinate is A and F of A. And we have the Q. The coordinate is something like X and F of X because it's arbitrary. This line is going to be called secant line. It's called secant line because it intersects the circle at 2 points. Now we can find the slope of a secant line. Why? Because I give you 2 points. See, that's a formula for the slope. So what's going to be the slope of this line? The slope of PQ is going to be equal to y2 minus y1, f of x minus f of a, divided by x minus a. Okay, so this is going to be the slope. This is going to be the slope of the secant line. Secant line PQ. Okay, now where is the tangent line now? So the way they describe it is they say, okay, this is the Q. Okay, so what we're going to do, we are going to move the Q. If you move Q in different position, look at this one. If you move it here, this is going to be Q. What's going to be your secant line? This is going to be your secant line. Again, you can find this one. Okay, that's going to be one. Then you move it again, move it closer and closer. You move it closer and closer to the P. You see, this is another one. This is the Q. You connect and you continue. You see, you connect, you continue. This is again is a secant line. But as Q getting closer and closer to the P, you see, then you are not going to have 2 points. You are going to get only 1 point. At that time, you see, at that time, you get the line that would intersect the circle at 1 point, and that line would be exactly the tangent line that we are going to be interested in. So what is the tell you about the procedure? The procedure is to see, look at this one, this quotient. This quotient is the slope of a secant line. When you move at different times, you get different x's. So you find these values. As you find this value, as the point Q getting closer and closer to the P, this quotient can be estimated. It would be estimated by a number. That number is going to be the slope of a secant line. Now you know the estimation. Your estimation is going to be the limit. Then you'll be able, you'll be able to find it. So we are going to copy this idea for our problem to be able to do it. Look at the problem that we did have. You see, this is your problem. You see, this is the problem. So what we are going to do, we do the same thing here. We start with the secant line. Any questions so far?
Can you move up the page up to the first ones? I missed the first one.
This is the first one.
The explanation on top of that, please.
That's it.
Yeah, thank you.
You see, this is going to be the case. So what we are going to do is we are going to do the same thing to this line here. We have the P, we pick a Q. Then we move it. Let me just do it on the curves. That's history. You see, that's a piece of history. In a minute, you will find out that this is what you do in everyday life. You do it in business. If you want to project what's going to be your income for the next 6 months, what will happen to the coronavirus? Okay, in 3 days times, they're going to be all the same thing. So let's do it in that curve, and at the end, it's going to be a formula. But it's very important to understand it first. Okay, let's do it again on that curve. That's the idea of the Newton for the first time. He didn't publish it. A German mathematician, his name is Leibniz or Leibniz. He published the result, but he didn't mention the name of the Newton. So there was lots of argument between the, he was German and the Newton is English or the British. So there is this challenge or argument historically between these two. There are quite a lot. Okay, so let's check it on the graph that we have. You see that suppose this is your graph. Okay, this is your graph, and this is the point P that you start with again. You see that we get the A here, and that was the P. So what we do, we pick another point. You can pick anything you like. You see, if you pick another point here, the X coordinate, you call it X, and this is going to be the point Q. Okay, so now we got those 2 points that I talk about it. So I have the point P, which is going to be A and F of A. And I have the point Q, which is going to be X and F of X, okay? So I can connect them together. That give me a secant. Okay, that's one. I connect these two together. So that gives you a line that intersect the graph at 2 points. So that's going to be your secant line. So the slope of the MPQ is going to be F of X minus F of A over X minus A. Okay, so what we do is we are going to move the Q. You see, we make it closer and closer to the P. As you move it, you see, if you move it here, this is going to be your Q. Again, you see, again, we get a line that's passing through 2 points. So this is going to be your X. But as getting closer and closer and closer, eventually you're going to have the line that intersect the graph at 1 point only, and that would be the tangent line. So the procedure is going to be, that's it. This is going to be the slope of a secant line. Say that the note that, say that's going to be the procedure. Note that Note that when Q is getting closer and closer to the P, okay, to the P, then at the slope of a secant line, you see this, the slope of a secant line, which is going to be MPQ, that would getting closer and closer to the, let's say, M, which is going to be the slope of the slope of a tangent line. But you know that you can write down in the language of the limits. So this means the limit of these numbers that we estimated for the slope of a secant line, when the Q goes to P, is going to be equal to the M, which is going to be the slope of your tangent line. But what is this one? You see, that's just the slope that we have it. It's f of x minus f of a over x minus a. When x goes to a, you see Q getting closer and closer to the P, if x getting closer and closer to the A. So that would be changing to the x goes to A, and that give you the M. So the secant line in limits is going to be the slope of a, this is the slope of the tangent line. Okay, as we did, this is the way we do in calculus. We estimate, we project something for future. So in order to find the equation of a tangent line, now we know what to do. We are going to make this, we find this quotient first. Limit of f of x over x minus a, x goes to a. This is one of those limits that you did it before. So as soon as you find it, this m is going to be what? This m is going to be the slope of a tangent line. So you have the m and you have 1 point, you put them together, that should give you the equation of the equation of a tangent line. Okay, any question? Let's give you one very easy example. Then of course, this limit takes time to find. So what we're going to do in a minute, we are going to call this limit the derivative of the function. So we introduce derivative, then we have a new machine. We can apply that machine to find the slope in future easily. But for the time being, we have to apply at least one example to show you that this can be done. Okay, so that's the idea of calculus. So we project something, you see this is the one. So we want to something happen at the point P. We go a little bit to the right or to the left, we pick another point like Q. So we fix it first. We fix it by 2 points, we find the slope, but that would be the slope of a secant line because you have 2 points. The line intersects the graph at 2 points. Then you want to make it 1 point. So you have to move the Q, getting closer and closer to the P. So this means this X must get closer and closer to the A. And eventually this limit would be the slope of a tangent line. Let's give you a real example. And then we introduce the derivative of the function. So what's a real example? You see, you have a couple of them at this level in your book. And this is the way you're going to solve it just for a minute. Let me simplify. We'd like to find the equation of a tangent line. The equation of a tangent line. Tangent line to the graph. To the graph of this function. Of the function f of x equal to the x squared at a point with, let's say, x equal to, how about x equal to 2? Okay, so the function is f of x equal to the x squared. Okay, this is your function. And the point is the point x equal to, okay, x equal to 2. Okay, so in order to do it, we just do exactly as we talk about it. We need a point and the slope. So solution, you need a point. What is the point? The point would have x and the y coordinate. X is given to you. Drop it into the function, then give it the y. Okay, so step 1 is x is equal to 2. So you find f of 2, which is going to be 2 squared, and it's equal to 4. So what is your point P? Your point P is going to be, the coordinate is 2 and, okay, 2 and 4. So that's a point P. Any question? We pick the Q because you have to form the slope of a, okay, the slope of a secant line. So pick Q. You can pick anything you like. So Q, the coordinate is X. You drop it into the function, the Y would be X squared. So that's a P and Q. Okay, now find the slope of a secant line. The slope of a secant line, remember the slope of a MPQ is equal to the formula. Y2 minus Y1 over, let me write it down for you, Y2 minus Y1, X2 minus X1, substitute. So MPQ is going to be equal to Y2 X squared, Y1 4 over X minus 2. That's the slope of a secant line. The slope of the secant line. Secant line. So what's the slope of a tangent line? You take the limit when X goes to 2. Okay, just estimate it. Any question? So we pick a point P. P is a fixed point, 2, 4. We pick another point, anything you like. So that's why we call this one X. X can be any number. Then we have 2 points. We write the slope. Y2 minus Y1, X2 minus X1 is going to be the slope of one of the secant line. So we move the Q. Remember, we move the Q towards the P. This means we find the limits. So this is also a formula. So the slope of a tangent line, M, is equal to the limit of the slope of a secant line. So what do you have? You have X squared minus 4 over X minus 2. X goes to 2. You have to find this limit. Any suggestion? But how we're going to find this limit? Suggestion? You have done it before, so
Would we substitute the 2 for the x's?
excellent. Yes, we substitute. So that give it 2 squared minus 4, 2 minus 2. So that give it 4 minus 4, and this is 0, 0. What's the message now? Zero, zero.
There's a common factor,
Excellent. What's the common factor?
x minus 2.
Very good. X minus 2 is a factor. It's a common factor. Is a common factor. So you know that you have to go back, factor it, eliminate it, and take the limit. So there you are. So the limit of, so x squared minus 4 now is going to be x minus 2 times x plus 4, x plus 2. And this is x minus 2 when x goes to 2. You have the common factor, eliminate it. See, you will see that we did everything we need before. So it's going to be limit of x plus 2 when x goes to 2. Substitute. So that gives it 2 plus 2, which is equal to 4. So 4 is the slope of a tangent line. M is equal to 4. We get the secant line. We estimate the secant line. When you estimate it, this is where that Q is getting closer and closer to the P. Okay, so when the P getting closer and closer to the P, you are not going to have a secant line anymore, okay? Because the graph would intersect at 1 point only, okay? So we have a tangent line. There you are. What we have a point, remember, the point is 2, 4, and the slope of 4. Formula for the equation of the line. Y minus Y1 equal to the M times X minus X1. Substitute, that's your X1 and the X, this is your X1, and this is going to be Y1. So what is going to be? Y minus Y1, which is 4, is equal to the m is equal to the 4 times x minus x1, which is 2. You have to simplify it, of course. So that gives you y minus 4. You substitute, sorry, you distribute it 4x minus 8. You add the 4. So y would be 4x minus 8 plus 4. So y would be 4x, okay, 4x minus 4. This is going to be the result. This is what? This is the equation of a tangent. The equation, okay, of the tangent line. Of the tangent line. You see, this is the way we are going to operate to get these numbers done. Okay, any question? So what we are going to do, we are going to translate it in minutes into a tool, okay? Because this is easy, you know, this function was easy. F of x equal to the x squared, okay? But if the function is getting complicated, this type of procedure, it can be done, but it's not going to be easy. So what we are going to do, you see, we check to see what we need. Remember, we need the slope. So what was the formula for the slope? Look at this one. A point P was given to you, then you pick the point Q, and this limit is going to be the slope. This limit, we are going to define it to be the derivative of the function. So we introduce a new machine, then we create some formula for the machine because it's going to be a new function. That will help us to be able to solve this problem, okay? So we plan the problem, now we are going to simplify it. So the simplification is going to be the topics of this section. What is going to be the derivative of the function? The derivative of a function. Our definition is a little bit different from your book because this definition is much better. But it doesn't matter if you want to use your book, it's up to you. But you will see the way we do it, this is just history. And we get eventually to what you have in your book. Okay, what's going to be derivative of a function? There you are. Suppose you have a function, okay? So we be given a function f. So suppose, okay, suppose f is a given function. F is a given function. And a is a number. Is a number in the domain of the function. Okay, it is going to be in the domain of the function. Domain of the function. Domain of the function. It must be in the domain of the function, otherwise, you know. So the domain of the function D, if you like. Now, we are going to, the first expression that we're going to use, f is said to be differentiable. F is said to be differentiable. That's the expression that we have to know for the rest of the course. Differentiable. Differentiable at a, at x equal to the a. Differentiable. It's going to be differentiable if this limit is just the slope of a secant line. You have to talk about it. If the limit of f of x minus f of a over x minus a, when x goes to a, exactly, you see this quotient is the slope of a secant line. And remember, when you take the limit, that limit gives you the slope of a tangent line. So we say f is said to be differentiable at x equal to a if this limit exists. Okay, if this limit exists, in that case, we say that the function is differentiable. Exists means if you can find it. Now, in this case, you find this limit is going to be a number. That number called the derivative of the function. Okay, so in this case, means if you can find it, in this case, the derivative of the function, the other expression. Okay, the derivative of the function. Derivative of the function. This is going to be the second expression. Derivative of the function is going to be denoted by the notation. Okay. Are you done? I have to go to the next page. It's going to be denoted by f prime of a. F prime of a. Denoted by f prime of a, and is defined by this limit. And is defined by, so I'm going to give you f prime of a. Okay, are you done with this one? So f prime of a is going to be derivative of the function, and this is how we are going to find it. So f prime of a is equal to the limit of, that's exactly that, the slope of a tangent line. Limit of f of x minus f of a divided by x minus a when x goes to a. This is the definition of the derivative of the function. You see, exactly this is what? This is just the slope of a tangent line. As we, okay, it's going to be the slope of a tangent line that we created. Exactly. So since it's useful, you have to use it quite a lot. So we are going to introduce it as a machine. Then we are going to give you some formulas for this machine. So instead of using the limit, you can use those formulas, you know, to take care of the job. Any question? So derivative of a function at the point A. Now, if you can do this one for all the points, all the values in the domain of the function, you say, oh, the function is differentiable on its domain. Okay, so lastly, this is going to be the one. If, okay, if the function f, is going to be differentiable forever, is going to be differentiable. Okay, it's going to be differentiable, let's say, for all a numbers a in the domain, in D, the domain of the function, then we say that then f is going to be differentiable. F is differentiable. Okay, it's going to be differentiable on its domain. On its domain D. See, that's a situation that we're going to have for these type of functions. Any question? So that's the definition of the derivative of the function. Let's have one easy function to find it with this limit formula. And then eventually we are going to give you something, a shortcut if you like. But to see how we operate with these formulas first, okay? So let's have easy example, but at the end of tonight, we are going to give you the formulas and then you can use the formula. So let's take this function. You see, suppose f of x is equal to the x squared plus 5x. We want to find f prime of 2, for example. Derivative of the function at 2. Okay, so how are we going to find it? That's it. This is your formula. You see the formula? You replace the a by 2. Then you form that limit, and then you are going to find it. Okay. So what's going to be the solution? The solution is going to be, say, oh, a equal to 2. Write the a equal to 2 in that formula. So if you write the formula for a equal to 2, So what's going to be f prime of 2? F prime of 2 would be equal to the limit of, okay, it's going to be the limit of what? The limit of f of x, that give you f of x, okay, minus, that give you f of x and minus f of 2. F of 2. Replace it by x minus 2. X minus 2. That's the definition. Definition of the derivative of the function at x equal to the, okay, x equal to the a. No, the function is differentiable if you check it. If it's going to be differentiable for all, not, you have to check this limit. If you check this limit for all the values in the domain, then it's going to be differentiable for all values. But we are going to check it one by one. Okay, now, so what we're going to do, substitute. You have to bring the f of x, this is your f of x. Then you have to bring the f of 2, the difference, you see, simplify it and take the limit, of course, when x goes to 2. So let's simplify it first, then we take the limits, okay? So we say, oh, what is my f of x? This is my f of x. F of x is x squared plus 5x. This is my f of x. So what's f of 2? F of 2. Substitute. So that gives you 2 squared plus 5 times 2. 2 squared would be 4, and that is a 10, so that gives you 14. Okay, so that's f of x, f of 2. Subtract to get f of x minus f of 2. So what's going to be f of x minus f of 2 is going to be equal to f of x is x squared plus 5x minus f of 2, which is going to be minus 14. Minus 14. So I have the top. Divide by x minus 2 and take the limits, okay? So your f prime of 2 is going to be, f prime of 2 is equal to what? Is equal to the limit of the top f of x, which is x, you see, we simplified already. So it's x squared plus 5x minus 14. And that would be x minus 2 when x goes to 2. You see, this is one of the questions on your quiz, remember? You want to find this limit. If you substitute the 2, that gives you 0, 0 automatically. That's why we practice those 0, 0s for all the problems of the derivative. When you substitute and you get this quotient, all of them would be 0, 0. Okay? So if you substitute, you will see the 0, 0 here. 2 squared, 5 times 2, minus 14, divided by 2 minus 2. Okay, if we simplify the top, 5 squared, 2 squared would be 4. That gives you 10, minus 14, which is 0. And that gives you 0, 2. So that gives you 0, 0. That's it. You know the message. This is a common factor, and the common factor is x minus 2. So you have to go and factor it, and then simplify it, and find the derivative, okay? So we remind ourselves that x minus 2 is a common factor. Okay, it's going to be a common factor. A common factor. Okay, so this is going to be a common factor. So what we do, we simplify it. And so that give you what? That give you the limit of factor it. This is x minus 2. And this is x goes to 2. You know that one of the factor is x minus 2. And you find the other one. What's the other factor for the top? You see, you have the x squared and the negative 14. You know that this is would be x, a number. What's the number? So you get the negative 14. So you have a negative 2 already. Negative 2 times what would be negative?
7.
7. That's 7. That's it. Now we have the common factor. We eliminated it. It's, you know, when we take the, when you form the limit, it's all the problems that we did before. X plus 7. So you substitute 2 plus 7 would be 9. So that's it. So f prime of 2 is equal to the 9. So this means the derivative of the function at x equal to 2 is equal to the 9. And you know that this is the slope of a tangent line. You can form the equation of a tangent line. But for this problem, they just ask for the derivative of the function, okay, to get this numbers done. Any question? But as I told you, this function was easy to apply. So we are going to give a formula. But
Why-
yes,
Sorry.
question.
Why did the 14 become negative 14?
Because you have to have f of x minus f of 2, remember?
Oh, okay, thank you.
You subtract it, you get it. Any more question? So let's see what we did so far. So far, it's all geometry. It's all geometry. So we find the slope of a tangent line. But the question is going to be, how about everyday life? Okay, so how are we going to apply these ideas in everyday life? You are not going to have a tangent line all the time. So, as you know, the slope in everyday life, it means something else. So what we're going to do is, you see two different definitions in your book. So this is history again. So what we're going to do, we go to the everyday life and we use the same idea over here, okay? So I can give you different, different examples of everyday life that you're going to have. My neighbor, he's a policeman, and sometimes, you know, his daughter or his sons, they come and ask questions about calculus. He always argued that, oh, what is this calculus, that they are all have difficulties. I told him that the calculus is the way you ticket us, okay? So I'm going to show you how the ticketing of a policeman is going to be the same as this problem. And the result is going to be a new formula, if you like. It's the same thing that we use in, okay, in your book is going to be used and you use in science, okay? Then I give a definition. Let's see, everyday life problem. In your book, they call it rate of change, but I wanted to give this idea first. You see, the question is going to be, we need to talk about the velocity. So let's get a couple of definition first, because you need the velocity. In your case, it's going to be something else to call it. So everyday life problem, this problem of a tangent line would give us something that we call it rate of change. So let's see what's going to be rate of change. Remember, calculus is a study of rate of change. Rate of change of what? Rate of change of your money, your revenue, your profit. You're running a company, you're producing something. Okay, you're manufacturing cars. So you want to know what's going to be prediction for the next 6 months. What's going to be the rate of change in your production? What's going to be rate change in your revenue? So that's why we are going to, it's the same as problem of a tangent line, but we put it in the format of the everyday life problem. Okay, so I did give you the, you know, the slope of a secant line, and I take the limit, I get derivative. But instead of a slope of a secant line, you know that the slope in the basic definition of the slope is a kind of average value of a function. So we are going to look at it from this point of view. Okay, so let's see how we're going to connect it to the everyday life. We need a couple of definition from the past. There you are. If a function, then I give you that problem of etiquetting. If a function f is going to be defined, okay, defined on the domain, okay, domain D, that's a domain of the function, and we have 2 points, get 2 numbers, and it's the same as the one that we did before here, and x1 and x2. x1 and x2 are 2 numbers, are going to be 2 numbers, 2 numbers in D. Okay, one of them is smaller than the other one. Okay, suppose x1 is going to be less than x2. Okay, you pick two numbers, any two numbers you like. Okay, so then the average rate of change. So that's going to be the case. Then the average rate of change. Rate of change. Average rate of change of the function. Okay, of the function. Average rate of change of the function from x equal to the x1 to x equal to the x2 is defined by it's the same thing, the slope. You see, it's going to be f of x2 minus f of x1 divided by x2 minus x1. You see, it's just the slope of a secant line again. Because it's going to be average rate of change. It depends what you have. In your case, if this f is going to be, for example, the cost function, so it's a cost of the production at two levels of production, x1 and the x2. So the top is going to be the number of the cars, cost of the number of the cars, for example. Okay, this is going to be the cost of producing x2 number of the cars. This is x1 number of the cars. So if you divide it, that give you average cost. This is going to be average cost in that level of production. The production depends on the x1 and the x2. If you take x1 to be 0, x2 to be 100, so if you are in this level of production in your company, that gives you the average cost. So when you know the average cost, then you can invest, okay, to see what's going on. So, but this is the average. It depends if you are in, okay, if you are in biology, for example, this function is going to be the growth function, the growth of the cancer cell, for example. So you consider the growth at two different times for the patient. So this quotient over here give you the average growth of the coronavirus, for example, okay, between this period, okay, for the last 6 months. So x is going to be 0, x2 is going to be 6. So it depends on the type of the function. If you get the revenue function, average revenue, you're going to see this type of problems. Average revenue, average profit in your case, average cost function, okay? So in geometry, we call it the slope of a secant line. But in everyday life, it's the average value. Average value or average rate of what? Average rate of change. The rate of change when you go from one level of the production to the other one. Okay. Now, just something from physics, because we need to add example. For physics, suppose, so in particular, you know, we just using the, okay, those business application, but this is nice to give you example that give better understanding for the example that I'm going to talk about it. Okay, so in particular, if they use f of t. F of t is your position when you drive on I-5, if you like, is going to be, is the position, okay, it's going to be the position of a moving object, position of a moving object, position of the moving object at the time t, okay, at time t. Okay, after 5 hours, we want to know where are you. So we find f of 5. If this is going to be the case, then you see this quotient that we talk about it, if you consider two different numbers, different t. So f of t2 minus f of t1 divided by t2 minus t1. You see the top is going to be displacement, the distance, the bottom one is the time. The distance over the time is going to be velocity. So this is going to be, this is going to be called, in this case, This is going to be called the average velocity. The average, okay, the average velocity. Average velocity of the moving object, of the moving object, from what? From t equal to the t1, for example, to t equal to the t2. Okay, so we usually give you one problem. We may talk about the the function business type, but it's going to be easy question. So I give you examples so that you're not going to miss it on the test. Okay, so we change it to the particular form, and the top is going to be distance in yard, kilometers, miles. The bottom one is time, seconds, minutes, okay, hours. So when you divide this, that gives us the ratio of the distance over the time, which is going to be velocity. But this is going to be average velocity. So average rate of change of your distance, if you like, that give you the average velocity. Let's have one example over here just for fun. And then we continue to get what we need. Okay, so don't be surprised. Some people on the test, when I give them this type of problem, they don't touch it. You have to get to application problems. These are the nice problems. So f of t equal to the t squared 4t plus 3. Suppose this is your position in miles. In miles. Okay, in miles is the position. Is going to be the position of a moving object, of a moving object in a period after t hours. So that's a formula. At any time we want to find you, we just substitute t equal to the whatever number we have. We find these numbers. So what they want, they ask you to find the average velocity. Find the average. Okay, average velocity in this case. Average velocity of the moving object, of the moving object. Moving object over this period, over the period of 1 to 3. So we watch you between t equal to the 1 hours, for example. It depends, okay, and the 3 hours. We want to know what's going to be average velocity in a special period that you are driving. What is going to be your average velocity, okay? So it's like finding the slope only. Okay, the formula that we are going to have. So this is going to be the solution. So what you have to find for us is just, this is it. F of T2, just the secant line, minus F of T1 divided by T2 minus T1. So you have 1 and 3. So you want to find F of 3 minus F of 1 divided by 3 minus 1. This is the average. Okay, this is going to be the average velocity. Okay, you substitute to simplify it, and that give you the result. Okay, let's see if you're right. So find F of 3, substitute. That's going to be F of 3. F of 3 is equal to 3 squared, 4 times 3 plus 3. 3 squared would be 9, 12, and 3. That gives us a 24. Okay, that's F of 3. Find F of 1. F of 1 is equal to 1 squared, 4 times 1 plus 3. So 1 squared is 1. That gives you 4 and 3. So that gives us 8. form this quotient. Okay, the difference between the distances and the time, and simplify it to get the final answer. Okay, any question? Just preliminaries that we have. So I'm going to the next page. I put the f of 3 minus f of 1, 3 minus 1 on the top, and I simplify it. That give me the result. Okay, so I remind you the formula. These examples, as I told you, give us a better understanding of the case, but everything would be simplified. But the average, this is the way you're going to find it. So that's going to be 3 minus 1 is equal to f of 3 was 24 minus f of 1 was 8.
Can you move it down, please?
Oh, I'm sorry.
Thank you.
Okay, so f of 3 minus f of 1, 3 minus 1, f of 3 is 24, f of 1 is 8, 3 minus 1. So the top would be 16, that would be 2. So the result would be 8. Of course, you have to give us a unit because this is velocity. The distance was in miles, so it's going to be miles per hour. Okay, so 8 miles per hour is going to be the average velocity. Average velocity. Nice, you see? It's in your case, we may say, oh, we give you cost function. And instead of f of t, we give you c of x. We call it a cost function, cost of producing x number of the cars. Then we give it two numbers and you find the average, okay, average cost for us. The average revenue, average revenue, average profit, etc. Okay, so that's the average rate of change. Any question? Again, I give you a break now. We come back. We want to find what is rate of change. You see, the way we did it for the geometry, this is secant line. This is the one you find. This is the slope of a secant line. Now we want to change it to the just the slope of a tangent line. So this is average rate of change. We are going to use the same procedure as we did before, and we find the derivative of the function if you like. In that case, the derivative of the function would be rate of change. You see, the average is not going to be good for you because what you would like to do for your investment, you want to find your profit, if you like, at any time you like. Again, this is average velocity. So when you be given a ticket, it's not the average velocity. It's the velocity at the time that the police would stop you. So we want to know how we're going to find that average velocity, or sorry, the velocity. We call it instantaneous velocity or the rate of change. So let's have a short break, then I give you that one, and that would be the formula that will help us to be able to build up some function and make things easy at the end. Okay, so it's 8:17, let's have 10 minutes. We come back at around 8:30. Then I introduce that formula for you. Okay, any question? Again, as I told you, we would like to get this concept, to understand it first. Because I know that at the end of the night, I give you a formula and then you apply the formula over and over and over. But you should be able to apply it in everyday life, especially in your fields. And you have some very nice examples. Okay, so be patient, but we get to that part in 10 minutes. Okay, see you in 10 minutes. Okay, so any question so far? So we define the average rate of change. For the average rate of change, you have to have an interval to be able to do it. You see, you do it from x1 to the x2. So the next question is going to be, suppose you want to find the rate of change at any time you like. So how are you going to find that one? Okay, so this is going to be the last question that we answer, and eventually we get back to the derivative again. So what is going to be the question? Again, we want to motivate this subject as best as we can. That would be very useful for you to understand the rest of the course. Okay, so what's the question? The question is, what is? Okay, what is the rate of change? What is the rate of change, not the average? Rate of change of the values of this function. Of the function y equal to the f of x at x equal to the a. It's exactly the same as the question of the finding the equation of a tangent line. Okay, what is going to be rate of change of the function at x equal to the a? Again, you see, we don't know what is the rate of change. Okay, but we know that the average rate of change is the one. So what we're going to do, that's exactly the way I talk about, the ticketing by the police. So what we are going to do is, in order to be able to solve the problem, okay, so what's going to be the solution? We know only average rate of change. So average rate of change, you need an interval. You see, this is A. This is A. So what we're going to do, we are going to build an interval. You have, this is A, you go a little bit to the right, or a little bit to the right, or left. So this is A. Let's get a number like A. Suppose A is equal to 2. Remember those estimates that we do it? So we pick a number like 2.001, 2.002. So we're going to call it A plus something. That's something, we call it H. In your book, they call it A plus delta X, that I don't want to use that method. Okay, I just call it H. So now we are going to have interval. You see, this is only the interval. A, comma, A plus H. Okay, so I pick any number I like, a number H. It cannot be 0. It's very small, but it cannot be 0. Then I can write the average rate of change of the function in this interval. Okay, and that's exactly how, you see, when you drive, this is the first time that the police car will see you. The car will see you at A. So the camera would watch you. So the way the camera of the policeman would operate is the camera is going to be watching you for the next few seconds, if you like. So the camera will build up an interval A and A plus H. Then the camera would watch your velocity. But that velocity is going to be your average velocity. You see, that's going to be one. Let's write it down. So what we're going to do is, suppose H is a number. H is a number. It's going to be close with H not equal to 0, of course. H is not equal to the 0. If this is going to be the case, then we are going to have the average rate of change or the velocity. Then the average rate of change, average rate of change of the function f over this interval. Okay, on the interval is A, comma, A plus H. Is, remember, f of x2 minus x1 divided by, this is still f of A plus H minus f of A divided by H. It's f of x2 minus f of x1, divided by the difference between these, A plus H, that's the x2 minus x1, which is a. Okay, that's f of x2 minus f of x1 over x2 minus x1. But you see the bottom one, this a and the negative a would cancel out. So what's going to be the result? The result is going to be f of a plus h minus f of a divided by h. See, that's going to be what? So this is going to be what? This is going to be your average rate of change, or this is going to be your average velocity. So as you're getting, you see, as you move, as you're getting closer and closer to the police car, this h would be getting closer and closer to the zero. So what we are going to do is we take the limit of this expression. You see the limit of f of a plus h minus f of a over h when h goes to zero. You see, when h goes to zero, this is going to be what? It's not going to be average rate of change anymore in this interval. Because when h goes to zero, you see, everything would be only a. So instead of telling it or calling it average rate of change in that interval, this is going to be simply is going to be the rate of change. Rate of change of f at x equal to a. But remember, it's the same thing. This is the slope of a secant line. When we take the limit, that gives you the slope of a tangent line. But you know that this is what? That we know that this limit is just f prime of a. F prime of a is equal to the, sorry, f prime of x. We go with the, yeah, that's what's the at a. F prime of a is equal to the limit of f of x plus h, f of a plus h minus f of a divided by h. This is the formula that your book is using for the derivative of the function, not the one that I gave you, which is not a very good one. I'm going to explain it, what's the difference between this one and the original one that we talk about it. So it's the same thing. Okay, it's going to be the same thing, but that gives you a nice application for everyday life. So when h getting closer and closer to the zero, in the case of the police car, you will meet the police and the system would register a number, 95 miles, 90 miles, they ticket you to get the numbers. Okay. So what is the difference between this formula and the other one? The difference is it can be done for any a. So you see the conclusion is going to be in general. Okay, in general. So what you can have is, in general, we have, if you look at this one, f prime of x is equal to the limit of f of x plus h minus f of x divided by h. H goes to zero. This can be considered as, okay, this can be considered, okay, can be considered as the rate of change. The rate of change. Okay, the rate of change of the values of your function. I call it predicted rate of change because that would predict, okay, this is my expression, which is quite useful, or predicted. Okay, predicted rate of change. Because when you get the ticket, you say they give you the ticket to prevent something. They know that for the couple of minutes, okay, the couple of seconds, you were driving with 90 miles per hour. So they want to predict to prevent it. So this is going to be predicted rate of change that we are going to have. Okay, any comments? So this is two formulas in your book. If you don't believe in this, you can memorize the formula, but it's not the way you understand calculus. Okay, so you have to compare them together. Geometry is just an excuse. Quotient line, that we talk about it. We can apply it quickly to the business to see what is going to be on. What's the question? Yes?
So this is just like the general formula. So it's like later on, if you put like actual values into it.
Yeah. It's a general because this is X.
Okay.
You see, we built a machine now.
Mm-hmm.
So we can apply it. The other one that I gave you right at the beginning, you can find f prime of 2, f prime of 5, but that gives you f prime of x. So you have a formula, and that is going to be more general one.
Okay.
Yes.
Thank you.
Okay, let's see if we can answer this question. Your field, from your field, we give you this question on the quiz, but you are going to find the derivative for us. But I give you the derivative. Look at this one. You see, suppose in your field, you are going to have cost function, revenue function, profit function. We go with the cost, C of X. Okay, suppose C of X is what? This is going to be, in this course is going to be used, is the total cost in dollars. Okay, that's dollars. So the total cost in dollars of producing, manufacturing, producing X number of cars, producing X number of cars. Okay. So if you consider C of 10, for example, you just consider cost of producing, 10 cars. So in general, it's going to be total cost of the producing X number of cars. So we would like you to answer these two questions. The first part, if C of 100, if C of 100 is equal to the $100,000, $100,000. Okay, would like you to tell us what does it mean? Okay, what does it mean? That's the first question. Let me write both of them, then you answer. The second one. The second one, if we give you that, if C prime of 100, okay, is equal to the, if C prime of 100 is going to be equal to the $5,000. $5,000. We want to know what does it mean? What does it mean? By the end, you are going to find both of them for us, but I didn't give you the function because we can't do it at the moment. Okay. Remember, C of X is the total cost of producing X number of cars. So C of 100 is equal to the $100,000. You want to know what does it mean? Okay. This is no. No, the function is C of X. C of X. That's a function. We don't have the function. We don't need it. C of X is what? C of X is the total cost of producing X number of cars. If they say C of 100 is $100,000, what does it mean? Any suggestion?
Would it mean that it cost $100,000 to make 100 cars?
Excellent. That's it, yes. Yes, the total cost of producing 100 cars is $100,000. That's it. Okay, because C of X. So this is how we answered the first part. Very good. Solution. Part one, the total cost of producing or production. Producing 100 cars is $100,000. We can use it for different, different things. In this case, we just talk about the cost function. Very good. Any question? Now, how about the second part? What is the meaning of C prime of 100 equal to the 5,000? I just remind you what C prime means. Look at this one. What is C prime? C prime is a rate of change of the function f, or as I like it, is a predicted rate of change, if you like. Predicted rate of change of the f. Okay. Any suggestion for a nice sentence? Okay, let's see. Do it word by word. What is the meaning of prime? The derivative in this case. The prime is what? Is the rate of change. Rate of change of what? Of the value of your function. What is your function? Cost function. So C prime means rate of change of the cost function. Rate of change of producing, okay, the function, if you like. So when we say C prime of 100 is equal to the 5,000, what are you predicting for us?
Would it be like the cost of producing an additional car after you have produced 100?
Excellent. That's it. Yes, that's exactly what it is. You see, C prime means the prediction. C prime of 100 means you are going to consider the rate of change in the cost of the production at the level of 100 cars. See, that's one, because the level is important. So C prime of 100 means the rate of change in the cost production at the level of 100 cars. So this means after producing 100 cars, okay, you're already done. After producing 100 cars, from now on, this is a positive number. So from now on, your cost would be increased. Your cost of production would be increased. How much? At the rate of $5,000 per car. That's the best way to express it. Okay, C prime of 100 is equal to the 5,000 is a prediction. Yes, in short, you are right. It's the cost of producing an additional car. Which car is that one? You said additional car. Which car is it?
The 100th one.
That's it, yes, the 101st car. Very good. You see, this means from now on, you see, from now on, if you want to continue for the time being, unless something else has happened, from now on, if you want to continue, because this is a positive, so this means your cost would be increased, if you like. Your cost would be increased by the rate of $5,000 per car. Sometimes this would be negative. If this is going to be negative, this means your cost would be reduced. Okay, it would be reduced by $5,000. Sometimes it's going to be zero. If it's going to be zero, means there's not going to be any change in cost. Okay, there's not going to be any change in the cost of production. So this is the way we'd like you to be able, to connect this type of problem for us. Okay, that's going to be, we could be talking about the cost. I use even this type of cost procedure for my calculus class 1, 2, 3 that I teach. I have, for example, biology measure and chemistry measure, etc. So we can make up something about it. But all of them is just a prediction. In your case, you may be given with the cost function, revenue function, or the profit function on the test. Make sure you understand it. If you understand this part, you enjoyed it, and from now on, anytime you want to talk about derivative phenomena problem, you already got the idea of what's going on, okay? So that's why I didn't start the definition by just giving you a formula right away. You want to check that one to get this one. Okay, so the first one is just the total cost of producing 100 cars. So the second one, nicely you explain it. The level of production is very important. You say after, I like this expression, you say after producing, because you have to give us the level of production. After producing 100 cars, after producing 100 cars, the total cost, the total cost of production will be, is a prediction, will be increased because it's positive, will be increased, okay, at the rate of $5,000 per unit, per car or per unit, per car or per unit. That's going to be one. Okay, or you can call it the cost of producing an additional car, means the next car. You already produce 100 cars, so the next one is going to be 101st car. And this is just an estimate, remember, this is an estimate, but if you want to find the actual one, you have to get the true level of production and you subtract it. You get C of 101 minus C of 100, so that gives you the exact cost. But we just want to estimate it. So this is how this type of interpretation that I put over here is going to be applied. Any question? So the derivative is the prediction, is the future. Calculus is the future. Okay, because with the calculus, we predict. Nothing is exact. We predict what will happen. You know, this is an estimate. Everything we do is an estimate because we do it by applying the, okay, we do it by applying the limit procedure. Okay, any question? Now we are out of the definition, so we are going to put it nicely together. So this is it. If you want to go with the limit all the time, that takes time. So why not? Let's make a new machine. So what's going to be this new machine? To give you the formulas, we are still in that section. Okay, it's very, very dense one, and we don't want to miss anything. So we are going to introduce, remember, we already got the function. The function is a machine. So we introduce a new machine. That new machine is called the derivative machine, the derivative function, not the derivative of a function, okay, as a machine. It's going to be what is the derivative function. What is the derivative function? You see, if I give you x, as I did it with that example, you drop it into your function, f, you get the output. Remember, the
Can you move it
output
down?
is f of x. Oh, I'm sorry. You see, that's a function machine. Okay, y equal to the f of x. We get the x, we drop it into the cashier, we get the f of x. That's a function machine. Now we introduce a new machine. What's that new machine? I give you, you know, you give me x, I drop it into the new machine. What is that new machine? F prime machine, rate of change machine. So the function, the result is going to be rate of change of the x, f prime of x. What was the formula for rate of change? Remember, this is it. Limit of f of x plus h minus f of x divided by h when h goes to 0. So you may call it y prime equal to the f prime of x. This f prime of x is called the derivative machine or the derivative function. Okay, the derivative function, because you know, if you find it, you see f of x equal to the x squared. So you find a new formula for f prime of x. Then if you want to find f prime of 2, substitute. F prime of 5, substitute. Okay, so we give you the definition. The definition is going to be, of course, you should be able to find the derivative. If, okay, if a function f is going to be differentiable, you can find all these limits. It's going to be differentiable on its domain D. Then we have a machine. Then f prime, new one. F prime is going to be called, f prime is called the derivative function. The derivative function. The derivative function of f, if you like. Okay, that's going to be the one. So we have a function and we have the derivative of the function. Let's find an easy one. Then we give a formula, and then you get the formula. You can use the formula and just go on. Let's check one example. You see, easy one. Suppose f of x is equal to the x squared. We wanted to find what is f prime of x. That's it. Find f prime of x. That's it. This is f prime of x. You substitute, simplify, that gives f prime of x. Okay, so you're going to do it. This would give you a general formula. Somebody say 2x. How do you know it's 2x? We have to prove it yet. Okay, yes, you are right. But I just want to prove it and give you the formula. Okay, there you are. Solution. The definition, you know the definition. F prime of x is equal to the limit of the rate of change formula. H goes to 0. F of x plus h minus f of x. It's just a secant line again over h. You have to form the limit, simplify it, and give us the f prime of x. Okay. So you better do it step by step. Let's find f of x plus h. So f of x plus h. F of x is x squared. You replace the x squared by x plus h. That gives x plus h squared. Square it or multiply by itself. X plus h times x plus h. FOIL it. But I'm going to square it and give you x squared. Twice after first times second, you multiply these three together. It's going to be 2xh plus the square of the second one, which is h squared. Or just FOIL it. That's f of x. Then I have that's f of x plus h. I have f of x. F of x is going to be x squared. Subtract. Because you need a difference. Subtract is going to be negative, negative. You see these two would cancel out. So what's going to be the leftover? F of x plus h minus f of x is equal to 2xh plus h squared. Okay, this is how you subtract it. Divide by h. F of x plus h minus f of x divided by h is equal to, divide this one by h, 2xh plus h squared over h. You can simplify the factor at the top. The common factor is h. So that gave you 2x plus h over h. Remember, h was not 0, so this would cancel out. So the result would be 2x plus h. That's this quotient. Take the limit. Okay, so f prime of x would be, f prime of x would be the limit of this quotient, the limit of 2xh, 2x plus h goes to 0. You know that it's a polynomial, you substitute. So that give you 2x plus 0, the result 2x. So f prime of x is equal to the 2x. See, we got the formula for it. So if you want to find f prime of 2, it's going to be 2 times 2, 4. F prime of -1 would be -2. F prime of 5 would be 2 times 5, 10. You see, that's the advantage of this formula. It's a more, it's a general formula. It's not like, you know, f of the one that I did, f prime of 1, f prime of 2. Okay, so this is the way we do it for the x squared. Let me generalize it and give you a very popular formula. So what we did is so far, so if f of x is equal to the x squared, then f prime of x is equal to the 2x. You see, it's like you bring down the 2 and you reduce the power by 1 unit. Similarly, you can do it again. Similarly, if f of x is equal to the x cubed, then f prime of x would be, you bring the 3 down, you reduce the power by 1 unit, that gives x squared. And then if you have f of x equal to the x to the 4th, then f prime of x is equal to, you bring the 4 down, reduce the power by 1 unit. Okay, that gives you 4x cubed, and you can go on forever. So forever means what? Means in general, if f of x is equal to the x to the n, any number, then what is going to be the formula? Then f prime of x is going to be equal to, you bring the n down, you reduce the power by 1 unit, x to the n minus 1. That's a great formula. You can use it anytime you like. We call it power rule. Okay, so it's going to be the power rule for the power rule for differentiation. So you are out of those limits that I've been doing it so far. From now on, we got the formula. We call it action of differentiation from now on, up through the end of the course. What is the action of differentiation? It is going to be n is on the top. You bring it down. Bring it down means you multiply the n by the coefficient. Coefficient is 1. N x to the 1 down, n minus 1. And then you can simplify it if you like. Okay, this is going to be called the power rule for the differentiation. N can be any number. Any question? So let's get practice on this one first, because we are going to check some different n. So n can be a counting number, 2, 3, 4, 5, 6. Can be a negative number, -2, -5. Let's give you all sorts of examples. And this is going to be a job from now on. And we give you more rules after differentiation. Any question? So you must know this formula by name. If you say what's the power rule, okay, this is going to be the power rule of differentiation, the power rule. Must know it. Action of differentiation. Exponent times coefficient 1 down. You see, n x to the n minus 1. Nothing else. Okay, so let's try various possibilities just to refresh your memory and prepare you for more complicated one for future. Find the derivative of each function. The derivative of each function. Okay, case 1. F of x equal to the x to the 5th. That's it. It's a power function, derivative, action of differentiation. Bring the 5 down, reduce the power by 1 unit. So the solution is going to be f prime of x is equal to the 5, x to the 1 dot. It's a 5 minus 1. I write it down, this is the first one. It's going to be 5 minus 1. So it's going to be 5x to the 4th. So f prime of x is equal to the 5x to the 4th. And you're done. Very easy procedure. Question. Case 2. G of x equal to the x to the negative 3. It's a negative number, doesn't matter. Okay, it doesn't matter. What's going to be the solution? G prime of x equal to, you bring the power down, negative 3, x to the 1 dot. Negative 3 minus 1, negative 4. And then you're done. Any question? Exponent times coefficient, 1 dot. Negative 3 minus 1, negative 4. That's the second case. What's the third one? Third one, h of x equal to x to the 1/3 fraction. Doesn't matter. Okay, solution. H prime of x equal to 1/3 x to the 1/3 minus 1. You see, 1/3 minus 1. Look at this one. 1/3 minus 1 is like 1/3 minus 3 over 3. So it's a 1 minus 3, which is a negative 2/3. So 1/3 x to the negative 2/3. And this is the way we're going to do it quickly. You see 1 minus 3. 1 minus 3 would be negative 2. Negative 2/3. Okay, x to the 1/3. So it's going to be 1/3 x to the 1/3 minus 1. Negative 2/3. And the final answer. Any question? So a fraction, what else? How about the negative fraction? F of x equal to x to the negative 2/5. Okay, negative 2/5. Solution. F prime of x equal to negative 2/5. X to the, you see, negative 2/5 is like negative 2 minus 5. That gives you negative 7/5. Negative 7/5. Quickly, you know, you subtract the top and the bottom always, that give you the final, okay, the final result. Yes, it's always 1 dot. The power is going to be 1 dot. Action of differentiation. Action of differentiation. You bring the power down, reduce the power by 1 unit. That's it. That's all we do. Any question? So let's see what else do we need. So we have a negative, positive numbers. So a couple of technical one. This is going to be your job. We're going to bring new formulas, but the basic is going to be the same thing. Now, the important, just tricky one, start with this one. Something to remind you. Okay, how about this one? F of x equal to the 5th root of x, a radical. Remember, we have only the power formula, power rule, power function. So what we're going to do is when it's a radical, we don't like the radical, we change it. We change the radical. Okay, how are we going to change the radical? Just remind you from algebra, you need this formula. Note that if you have the n root of x, the n root of x, you change it to the x to the 1 over n. In calculus, we don't like the radicals. Anytime you see the radical, you change it. We switch it into the power. Okay, this is going to be 1, and sometimes you may have this one, n root of x to the m. Again, this is going to be x to the m over n, m over n. So the index of the radical is on the denominator all the time. Okay, so anytime you see the radical expression in this course, switch it. You switch it, then you can, you can find the derivative. Any question? So let's get back to our problem. So for our problem, that was f of x equal to the fifth root of x. Rewrite it, we say rewrite it. If you rewrite it, that gives x to a fifth. That's it. Derivative of x to the fifth, you bring the fifth down, then a fifth minus 1. So f prime of x is equal to 1/5 x to the 1/5 minus 1 is like 1 minus 5, which is a -4. -4/5. And then you're done. In your book, they changed it to the positive power, the radical. I need just the calculus part. So that would be the end of the problem for me, okay? If we want to simplify it, we do it later on, but not now. This is the derivative of the function, nice. 1/5 x to the -4/5. Question? So it's a radical, rewrite it, give you another radical. How about this one? G of x equal to the is equal to the cube root of the x squared. You have to rewrite it. You have to use this formula. So it's going to be x to the 2/3. So the solution is going to be, we rewrite it, x to the 2/3. How we get the power rule? G prime. Bring the power down, 2/3, x to the 2/3 minus 1, 2 minus 3, -1, -1/3, the final answer. Okay, you subtract the top minus the bottom one, that give you 2 minus 3, which is a -1, -1/3, to find out the final answer. Okay, question. We have one more case to go. Then we put all of them together. It's not going to be our problem. We have a combination of these, but first we practice, then we get to the big one. The other thing that you have to know is this one. Okay, and the function is f of x equal to 1 over x to the 4th. Again, you see, we can do all the power function. So what we're going to do, we're going to use something else in algebra. You can bring this one up. Remember to bring it up using this formula. That's the second formula that we do it in this course all the time. So if you have 1 over x to the n, you can move it up, write on as x to the -n. No fraction, no radical. That's a message. So if you have the fractional one like this one, 1 over x to the n, you bring it up. When you move it up, this is x to the -n, so we can apply the power rule. Okay, so you have to rewrite the radicals, and then you have to rewrite these fractions for us, okay? So there you are, what you are going to have now. We have f of x equal to the 1 over x to the 4th. Move it up, x to the -4. Differentiate. F prime equal to f prime. -4 done, -4 x to the 1 done. -4 minus 1, don't be set there, -5. So that gives you the final answer. Any question? So these are a combination of the tools that we need, but we put a couple of them together and then we differentiate it. Now, what's going to be the last one of this review? Number 8. That's interesting. Some people, they miss this one. G of x equal to 1 over the 6th root of the x to the 5th. Any suggestion for this one? Any suggestion? You have to, of course, rewrite it, okay? You have to rewrite it. And we have x to the, somebody say x to the what? Negative 5, 6, you are right. You see what we are going to do? We have a fraction and the radical at the same time. So remember, we remove the radical, that gives x to the 5, 6. Based on the denominator, you have to move it up. So that gives x to the negative 5, 6. So I do it in 2 steps, so you understand it. You see, the first thing, I remove the radical, 1, x to the 5, 6. So I remove the radical. Then I have to move this one up, x to the negative 5, 6. That's it. Don't miss that negative sign, because the radical is on the denominator and then you move it up. Okay, question? Now we can differentiate it. Power done, negative 5, 6. X to the 1 done, negative 5 minus 6. That gives negative 11, 6. Okay, if you don't believe it, negative 5, 6 minus 1, it's going to be negative 5, 6. And you write this one as a 6, 6. So that gives a negative 11, 6. But that short form is, you see, negative 5 minus 6. Negative 5 minus 6, that gives 11, negative 11, 11, 6. That's it. We are done with the power rule. We have to give you a couple of more rules, like because we put them together, you know, it's going to be addition of these terms. So what we did, we covered section 2.1. Okay, that's 2.1, the preliminary definition that we have. And we also cover 2.2.